Hey folks, how's it going? So today we're going to be looking into this problem called monotonic array. So this is quite an interesting problem. It does not require like special data structures. As you're going to see, the solution is going to be quite intuitive. Anyway, monotonic array can come into two ways. One could be it is increasing, and the other could be it is actually decreasing. So this is just a very complicated explanation, but what they're trying to say is that monotonic increasing is nothing but an array that is sorted in an increasing way. So by that I mean, let's say you have like, one, two, three, four, five, six. These numbers are increasing, right? These numbers are going all up, right? As we can see that like the value at I position is always going to be less than or equals to the value at J position. So that's what they mean, right? So now let's look at the opposite, monotonic decreasing. So monotonic decreasing is nothing but essentially the values are going to be decreasing, right? It's just the opposite of what you just did. So this is going to be 2, 1. So these values are going to be decreasing like so. So what this means is that the value at position I should be greater or equals to the value at position J. And in this case, this is the case. I6 is greater than J, which is 5. And that's like that, right? So that's what it is to this. Now that we understand monotonic decreasing as well as monotonic decreasing, what does the question actually want from us? So we're told that given an array nums, return true if the array is monotonic or false otherwise. So essentially what they're saying is that if an array is it like monotonic increasing, we return true. If an array is monotonic decreasing, we return true. So we return false if an array does not meet none of those conditions. So let's make an example so that we understand. So let's say we're given this array here, 1, 3, 2, right? So this array, if you look at it closely, we can see that it's not actually decreasing as well as it's not actually increasing. This is because like we start at 1, we go to 3, but we go back down to 2. So it's something like, you start at 1, you go to 3, you go down. So this is not increasing and this is not decreasing, right? So this is where we return false. Does that make sense? So let me repeat this. So essentially, this is not increasing because of we can see that when you're at 3, we go down to 2, right? And this is also not decreasing because of if it was decreasing, then we were going to start with a bigger value, not 1. So this solution is just not going to work. This problem is going to be false, I meant to say, right? So now, given all of this, uh, we need to come up with a solution then. Try to firstly solve the monotonic increasing, right? This will probably give us a good idea of how we can come up with a good solution, right? So let's look at this array here, 1, 2, 3, 4, 5, 6, right? The question is how can you detect if this is monotonic increasing or not, right? We only focusing right now on monotonic increasing. So we do know that, okay, we've been told that, okay, monotonic increasing, essentially the I value should be less than or equals to the jth element, right? So which means that we can have um, a pointer which is going to start at the first position, which is L, 0. Then we can have a pointer which is going to be the length of the nums of the array minus 1, right? We're going to have a loop. So this loop is just going to go through the element within this array. So we're just going to say while L is less than R. So this is just to ensure that we don't go out of bound. Then we're going to say end, right? Nums of L, so which means that we are currently pointing at L at this value here. If that value it is less than or equals to nums I plus L plus 1, right? So which means that we are pointing at this is L plus 1, right? We are pointing at this second value. So what we are saying is, as we are asking ourselves, is this element less than or equals to the next element? That's what we are doing, right? Then if this is true, what we're going to do is that we're going to say L plus equals to 1. So we're incrementing L, right? So the first loop is going to be true because of 1 here, it is actually less than or equals to 2. So which means that we're going to increment this. This is going to be 1. Then we go again, the loop goes again, the while loop goes again because this is going to be true. So um, because of L now will be here because it's at position 1. So we're going to check this. This is going to be true. So we know these elements, all of them are going to be true, right? So but the thing here that we need to observe closely is that when L comes here, like when L is at the last position, that's where we can say return L equals to R. Because of now, which means that we are at the end, the whole entire array essentially um, is sorted in an increasing order, the whole entire array, right? So this is going to return true because of L will have reached the last element. So let's make an example whereby this wouldn't be true. So let's make it the same example. We're still taking the same array. So let's say we have 1, 2, and we have 1. Then we have like 3, 4, 5, 6. So we know that this is not true. This is not increasing because of we can see we have 1 here. So this is not increasing, right? So what will happen with the while loop, right, is that when we say that nums I is less than or equals to um, what is it, L plus 1. So this position here won't be true, right? So which means that L here won't be the length of the array, won't be here because it will have the while loop will breaks from here, right? The L won't get to reach here. So that's why here this condition won't be true, right? So that's how we're gonna solve this problem. So we're gonna have two functions. One is gonna handle the monotonic increasing and one is going to handle the monotonic decreasing. So when it's monotonic decreasing, we just change the condition. That's the only thing we change is that equal greater than or equals to. But the idea is still the same. I hope this makes sense, guys. But if you still don't get it, I promise you will get it when I start to code it out. So let's get into the code. So the first thing that we're gonna do is that we're gonna have the function that we spoke about. So the function we said that it's gonna be increase mono. Then here we're gonna take the nums as well as we're gonna take left and right. Um, then we're gonna do the same thing that we did in the whiteboard. Essentially, nothing will change. So we're just gonna have a while loop in which we're just gonna say as long as L is less than R. So this is to make sure that we don't go out of bound. Then we just say L is actually going to be less than or equals to the nums at L plus 1. So we're checking the next element as we do that. Then we're going to increment L plus equals to 1. And when we are done, we're just going to return L equals to R. So whatever this returns, we know if it returns true, this is going to be increasing mono. If it returns false, we know that this is going to be is not going to be a valid. So it's okay for us to return false. Now we're going to do the same thing, but now we're doing it for the decrease mono. Um, so this is going to be self. We take nums. Also, we take the left pointer. We take the right pointer. We literally the same code. The conditions. That's where like the difference is. Here we're just going to say nums at position L is greater than equals to nums position L plus 1. So because we're checking the increasing, we're checking if the values are decreasing. So the previous element has to be greater, right? Um, this is going to be L plus 1. So here we're just going to say return L equals to R, right? So the idea with this condition is that essentially this loop will break if this condition is not true. Then that's when we know that, okay, this is not decreasing monotonic, right? It's just this value, this array was not increasing or decreasing, right? So now we're going to have actually, I think we can actually do it inside the main function. So I'm going to take these two functions out. This is just for making this function much more better to read. So I'm just going to put them there. So that's fine. So what we need to do now is that we just need to call those functions, but it's going to depend how we call them. So the first thing that we need to know is that if we only have one element inside an array, this is going to be true, right? So if num's length equals to is less than equals to 1, then we're just going to return true. This is because one element could be increasing, could be decreasing, so it's fine for us to return true, right? So this is where we have to call increase mono or decrease mono. But the question is, how do we call increase mono and decrease mono? So we can check the first element as well as the last element, right? So if the nums I at position 0 is actually less than or equal to nums at position the last position, so we know that here essentially this is going to be increasing, right? We're not 100% sure, but the assumption is that it's okay for us to call like um, increase mono. Let's take example like this. So we can see that here it is 1, right? And the last element is 3. So we can see that this is essentially increasing, right? So it's okay for us to call this decrease function, right? So that's what we're gonna do. So we're gonna say return self dot increase mono. Then here I'm gonna pass the nums. I'm also gonna say 0, which is gonna be our left pointer, and the length of nums, which is gonna be the right pointer. Then I'm gonna say else. Um, I think it's gonna be else if nums gonna be num 0. This is gonna be greater because we're looking at the decreasing. So it's greater than the last element, which is gonna be minus 1, right? What we need to do in this case, we just need to return self dot decrease mono. This is gonna be nums. We pass the same parameters. Okay, so this is gonna be 1. So if I submit this, ideally this is supposed to work, but so did I make a mistake? I think I did, right? I think it's supposed to be L if. Yeah, it works. So yeah, this is like the pretty much the solution. So yeah, it wasn't that hard and it's quite efficient as you can see. So yeah, thank you very much guys for tuning in. I'll see you guys in the next one. Thanks, bye.